Another Earth Science video. Here we go. Norris teaches science here with me, Mr. Norris, and today I present to you maps. Maps are really important in Earth science. It does require, most things in Earth science requires you to read a map, somehow, some type of map. So, by the end of this video, I can read and understand information that is contained within a map. When we look at maps, maps have two main parts. You either have lines of latitude or lines of longitude. Latitude lines are lines that go across. So they measure distance north or south of the equator. Longitude lines that go up and down. And they measure distance east or west of the prime meridian. So I mentioned two things here, equator and prime meridians. Those are major lines on Earth. The prime meridian is a 0-degree longitude line. You can see that right here. It passes through a place called Greenwich, England. And if you look at the prime meridian, if you look to the left, that's the western hemisphere, and you look to the right, that's the eastern hemisphere. The equator goes across 0 degrees. It indicates the tropics. If you go above the equator, you're in the northern hemisphere, and if you go below the equator, you're in the southern hemisphere. So let's use this to figure out latitude and longitude of 3 points. Before we start, I like to indicate where my equator is and where my prime meridian is. So I'm going to use the yellow highlighter. Equator is a line that goes across, it's 0 degrees, so here's the equator right there. Then change the color, I'm going to change to purple. In purple, we're going to do prime meridian. Prime meridians go up and down, and that goes right here. So getting the pen, we're going to figure out the points of these three. So here's point 1. So we look here. The first thing we want is the latitude. Latitudes go across, so you go to the point and you go across till you get to a number, and that number is 30. It's 30 degrees, but you need to indicate is it 30 degrees north or 30 degrees south. That's where you look at your point. Is it above the equator or below the equator? If it's above the equator, then it's 30 degrees north. The next thing we need to do is we need to figure out the longitude line. We go back to our point, and longitude lines go up and down, so we follow the line up or down till we get to a number. This one says 120 degrees. With longitude lines, you need to write, is it west or east? You figure that out by going to your point. Is it to the left or to the right of the prime meridian? The prime meridian's in purple. We're to the left of it, so it will be west. Point 2, let's do the same thing. We're at point 2, we need to figure out the latitude. We go across, we see that latitude is at 75 degrees. We need to figure out, is it north or west? Well, is your point above or below the equator line? It's above, so it's north. Longitude, we go back to our point. We go up or down till we get to a number. This one's at 60 degrees. Then we need to figure out, is it west or east? We look at it, compare it to the prime meridian. It's to the right of the prime meridian, so that means east. And there's points 2's latitude and longitude. Then we have 3. 3 is right here. If you look, it's where the prime meridian is intersecting with the equator. That means that 0 degrees latitude, 0 degrees longitude. There are many different types of maps out there. You have the Mercator Map, which shows that instead of having the curved longitude lines like you would see on a globe, it makes them all parallel with each other, and it makes these rectangular grids. You can see those rectangular grids right here. We use this for navigation because direction is accurate. The problem is sizes and distances are distorted. It takes distance, making some things farther apart and some things closer together, but it also changes the sizes of the continents. The most well-known one is Greenland. Greenland shows to be bigger than the United States, and we know for sure that's not the case. The next one is called the Robinson Map. The Robinson Map is shows kind of the curvature, and it's one of the most widely used ones because it shows distances correctly, it shows its sizes correctly, and it shows its shapes correctly. The conic map, this is used by wrapping a cone around the globe at a particular line of latitude. Usually we use this for road maps and weather maps. A gnomic map, because the G is silent, sailors use it for direction and distance across the ocean. And the last type of map is called a topographic map. You can see that in this picture here. It shows elevation of land masses using something called contour lines. A contour line are lines that connect the same elevation. We're going to see that a little bit better here in reading this topographic map. So we have a topographic map, we have some elevations indicated, and then we have lines in between that don't have their numbers on them. Usually there's a set scale for what each contour line represents. If you look here, we need to go from 800 to 4,800 feet to 5,000 feet. So each contour line would be 50 feet. All right, so we need to figure out about what you would use it to figure out the elevation of different points in the graph. I really hope you learned something today. This is Mr. Norris, and I am signing out.